So in our last video, we discussed equations with variables on both sides, but when this happens, there are some weird things that can occur. So this video is going to discuss the two special cases we possibly have, I should say, with variables on both sides. So we're going to start solving these like we did in our last video. We're going to make sure each side is simplified before we see, what's that weird thing that's kind of happening here. So on number one, on the left-hand side, I do have some constant-like terms. So those are going to become 4x and minus 6. On the right-hand side, I have some parentheses. So I'm going to distribute first. So we end up with 3x plus 3, and I still have my plus x. So my left-hand side, there's nothing else to do there, so I'm just going to bring that down. But on my right-hand side, I do have my x's to combine, and I end up with 4x plus 3. And some of you are going to realize right now that something weird is happening. Some of you might need to take that extra step and say, oh, I'm going to try and get my variables to the same side, and then you'll see that something weird happens then. Either way is fine. But really, if I had, I'm going to just jot this on the side, if I had 4x equal to 4x, I hope we can agree that that would be a true statement. Okay, both sides are the same. But now what's happening is we have this 4x and 4x, but on one side, we're subtracting 6 from it, and on the other side, we're adding 3. There's no possible way that those two sides of the equation could be equal. It's kind of like we got a faulty equation. They said, here's an equation, try to solve it, but it wasn't a really good equation. So in this case, it's what we call no solution. Nothing will work in there. There is a little symbol. I like to think it kind of looks like this no smoking sign, but it looks like that. Okay, either one is fine. You can write out the words no solution, okay, or use that little symbol. Okay, if you don't recognize it there, what's going to happen? Actually, I don't. I'm going to get rid of that line. What's going to happen is you're probably going to say, oh, I'm going to subtract my 4x to get rid of it. But I get rid of it there and there, and I end up with negative 6 equal to 3, which is an untrue statement. Okay, so if your variables completely disappear, okay, and you get something that's not true, that's also when it's going to be no solution. So in general, if we're trying to recognize it at that step right there, we're going to have the same amount of variables on both sides, but maybe different constants going on. Oh, different constants. Okay, where it would not be equal. That's when it's no solution. Okay, on number 2, okay, I have some parentheses, so I'm going to distribute. We get negative 6y minus 14 equals negative 6y minus 14. And in this case, we get the same exact thing on both sides, which means anything you put in for y is going to make sense. Because on the left side, no matter what you put in for y, you'll multiply it by negative 6 and subtract 14. On the other side, you would multiply it by negative 6 and subtract 14. It's going to be the same thing in the end. Okay, so this is what we call all numbers, is one way of saying it. You might see infinite solutions, meaning, there's an infinite amount of possibilities. Okay, you might see all real numbers. Okay, there's lots of different things you can say here, but essentially you're saying there's so many possibilities of this. There isn't just a one single y equals answer. Okay, so this is when you get the same exact thing on both sides. Not only are your variables the same, okay, but your constants are also the same. If you kept going, what would happen is you'd add 14 and add, oops, sorry, not add 14. What am I doing? Sorry. We would probably add 6y to get our variables to the same side, and we would end up with negative 14 equal to negative 14, which happens to be true. Okay. So those are your two special cases, no solution and all numbers. Just the last one, I do want to point out that after teaching no solution and all numbers, you guys want to get the tendency to use them all the time. They don't happen very often, okay? And what I do find is sometimes when the numbers don't work out nicely in the end, you're just kind of want to say no solution because you're like, yeah, the numbers don't work out nicely. But we've already learned that if the numbers don't work out nicely, it just means it's going to be a fraction answer or a decimal answer in the end. So something like number 3, nothing to simplify, but I would probably say let's add this 4x over here to move to the other side. So notice one was a positive 4x and one was a negative 4x. They were not the same amount of variables on both sides. But we end up with 8x plus 7 equal to -2. We would subtract that 7 from both sides and get 8x equals -9. And then lastly, divide by 8. And we're not going to say no solution because 8 doesn't go into 9. That's not how no solution works. Okay, we would just recognize, hey, this is our answer. So x equals -9/8. Okay, so once again, no solution in all numbers only happen when you have the same exact amount of variables on both sides after you simplify. And then it's a matter of, are they exactly the same? Or do you have different numbers then that make it not make sense?